Second in a series of videos about tractability and how it applies to your DCAT. So just to recap, the concepts covered in tractability relate to the limits of computing. What is it that computers can't do? And it brings in algorithm performance and a whole lot of maths. It's probably a first time that a lot of people have come across maths in computing. You recall that we were looking at the travelling salesman problem, and we were using the brute force algorithm, which is terrible, but very useful for illustrating the points, and very relevant indeed, although it seems kind of stupid. So what we're going to do, as foreshadowed in the previous video, was we're going to increase the number of cities, increasing the problem size. So this is something that comes up a lot when we're talking about algorithms, is problem size. And it's often not to do with absolute numbers of performance or anything, or data size or anything like that. It's more to do with how algorithms cope as the size of the problem increases. And the size of the problem might mean number of data points, the number of cities in this case, the number of items in a database, or whatever. Or how many things we're sorting, how many things we're searching. So it's kind of key to this concept, which is why I mention it now. So anyway, over to Microsoft Paint, and this is where we were before. We had our 4 cities. What I'm going to do is I'm going to add in a 5th city, E. Oops, that's not what I wanted to do. I want it to be in a brush size. Brush. Good thing I'm prepared, isn't it? Right, E is down here. Now, of course, E can appear at any point in the route. So the person could go to, for example, E first, and then to any of the other cities, and in whatever order. And in fact, what we could do is if I just go to black here, black, is I could just put an E, it's not black, but whatever, in front of there and say go E, A, B, D, C, D, and then I could go E, A, B, C, D. And in fact, I could have 24 routes where we'll go to E first and then the same lot that we did before. So that's 24. And then I could say, all right, what we're going to do now is we're going to put E as the second route. So we'd go A, E, B, C, D, A, E, B, D, C, A, E, C, B, D, etc., etc. So we'd have another 24 routes. And then it could go in the 3rd position, 4th position, and finally last position. So there's 5 different routes. So effectively, we have 5 times 24. So these 24 routes, but with an E city in a different place, and we've got 5 lots of those. So that's 120 routes. Now, then maybe we could end up with we could say, oh, we also need city F over here. And we put that in there, and the person could go to F first. And obviously, we're going to do the same thing. So we've got all of these 120 routes listed here. And we could start with F as the first place we go to, and then F is the second place we go to, etc., etc. And it turns out that would be in 6 different places. So we've gone from 5 times 24 is 120, and then we do 6 times 120, which is 720, I think. Yeah, sounds about right, doesn't it? 720. So what you may notice here is as we go up by 1 city each time, we multiply by the next consecutive number. And as I'm sure you've all realized, that this is a factorial. So effectively we're doing 6 times 5, and then 24 is actually equal to 4 times 3 times 2 times 1. So for, let's just see, A, B, C, D, E, F is 7 cities, isn't it? So for 7 cities, you do 6 factorial. So 7 cities, 6 factorial. Excuse the terrible layout here, never mind. And of course, then for 8 cities, yeah, that's right. For 8 cities, it is 7 factorial, etc. Now, the more keen-eyed of you may well have spotted that actually not all of these roots are completely different. So ABCD is pretty much the same root as DCBA but backwards. So a clever algorithm wouldn't do both. It would just say, oh no, these two are the same. So it's actually halving that. But as we will see in the next video, halving it doesn't solve any problems and is actually a bit irrelevant to the key concept of tractability. So what we've shown here is that the number of roots that you have to check for a brute force algorithm goes up as a factorial related to the number of cities as you increase the number of cities. And in the next video, we're going to look a little bit further into those factorials and just decide how much of a problem the factorial is. Here's a clue, it's a big problem. See you next time.